right, so now we're going to talk about types of neuroglial cells. In the book, you're going to see here a table with oligodendrocytes, ependymal cells, microglia, and astrocytes in the CNS, and Schwann cells and satellite cells in the PNS. So, types of neuroglial cells, number one, and I'm going to put here CNS. You have oligodendrocytes. And the oligodendrocytes, they form the myelin sheaths in the CNS. You have to know that the myelin sheath is 80% lipids. It does make it white. They are white because of the lipids, and they speed up the process of of nerve communication. So I'm going to put here oligodendrocytes. I think that's how you spell it. Yep, oligodendrocytes. Then you have your ependymal cells. Third, you have your microglia, which are your last line of defense. They're pretty much just modified white blood cells. You have astrocytes. The astrocytes, in a board question, they might ask you, are you aware that astrocytes make up the blood-brain barrier? Yes, you're aware. If they ask you that and it's super easy like that, then yeah, then astrocytes make up the blood-brain barrier. So, oligodendrocytes. Dendrocytes. They form the myelin sheath. Okay, that's that. For the ependymal cells, they actually, let's see, they secrete, hold on, they secrete cerebral spinal fluid. So they actually secrete and filter plasma from blood to create cerebral spinal fluid, CSF. Your microglia, last line of defense, and they are your modified leukocytes. Sorry, this is taking a really long time. Fourth, astrocytes, most abundant glial cell in the central nervous system. They cover the entire brain surface and most non-synaptic regions of the neurons and the gray matter of the central nervous system. So that's slide 12-30. I'll put here modified leukocytes. And astrocytes, most abundant in CNS. And you could actually see them in this picture here. Right there. Let me get that out of the way. So right here you have your neurons. They're dancing right here. Let's go in order. Your oligodendrocytes right here. Oligodendrocyte. They're like octopus. There's like an octopus here with arms everywhere. And when they stick, so this arm right here is sticking where my pointer is sticking at. It's touching the axon hillock or the trigger zone. Then here's the axon, grabbing onto the axon, wrapping itself around the axon to make whatever current is in there pass by a lot quicker. We didn't go over exactly how that happens, but we do need to understand that the myelin sheath or a myelinated axon, myelinated neuron, is faster. It does transmit information a lot quicker, and it's because of the oligodendrocyte that happens. And then in order, we saw the ependymal cells right here, this little caterpillar looking thing. Okay. They line the cavities of the brain and they create the cerebral spinal fluid by filtering plasma from the blood and creating cerebral spinal fluid that way. So it's pretty much a big filter, and it creates CSF. That's what you need to know. Microglia are these little guys over here on the bottom right. They look like little versions of neurons. They look darker, but they look like neurons, but they're just really, really tiny and really, really thin, I guess. I don't know. Last line of defense. So they actually they're like lysosomes in a way, because they eat away at foreign bodies. So he gave an example of syphilis. If he put on the board, he drew he didn't draw it, but he drew like little balls of little molecules or little particles or whatever of syphilis, and he was showing us how the microglia would attack it and eat it and digest it before it reaches our brain. Astrocytes, you see them, where the hell are they? Right here, these blue looking neurons right here with all of these little arms. They separate this capillary, right? It's a blood-brain barrier. So they separate this, holding on to it from the neurons. So pretty much, it's like when it's like breaking up a fight, all right? So you have one guy here, you have one guy here, and you're trying to get in the middle. At that point, you become the astrocyte. I know it sounds weird, but I think that's a good way to see it. It's kind of like in the way, holding on to a capillary and holding on to a neuron. It's very physical. Okay, so that's that. I'm going to put here blood-brain barrier. So that's that. So we know our type of neuroglia. Oh, Schwann cells and satellite cells. Last ones. So in the PNS, so neuroglia in the peripheral nervous system, we have number one, our Schwann cells. And you're going to see that on slide 12-32. They envelop nerve fibers in PNS, and they produce a myelin sheath similar to the ones produced by oligodendrocytes. So the Schwann cells are the oligodendrocytes of the PNS. So Schwann cells produce myelin sheath. And then we have number two, our satellite cells. He didn't say that we had to commit satellite cells to memory, but just you should understand that they regulate the chemical environment. I would still learn it if I were you, of the neurons. So Schwann cells produce a myelin sheath, so you can say that they are the oligodendrocytes of the PNS. So that's that. We also need to know that our brain, the white matter, is deep. He mentioned this. He did it. It's actually not on the book. Not that I know of anyway. No. So we need to know that the brain has white matter and gray matter. White matter is deep, gray matter is superficial. Everywhere else, white matter is superficial, gray matter is deep. White matter is the way it is because of the myelin sheaths. They are white because they're 80% lipids. And that's going to be the end of this video. For next video, we're going to get into multiple sclerosis, Tay-Sachs disease, conduction speed of nerve fibers, regeneration of nerve fibers, denervation atrophy, NGF, or the nerve growth factor, what a synapse is, presynaptic neuron, postsynaptic, synaptic knob, and maybe we'll get into the neurotransmitter groups.